Okay, so in this video we are building upon what we've been doing last video when we were looking at finding the zeros of a polynomial. We're going to apply everything we did there to now starting to graph some polynomials. And in this video we are mainly dealing with cubic functions. So if you remember our basic cubic from about a series or two ago, we were looking at the cubic function of y equals x cubed. And when we essentially graphed this out, we got something that looked something like this. And this thing just continues up and down here, and it had a y-intercept of 0, and all of these points along here obeyed this particular cubic rule. So our y value we got from taking our x value and cubing it. So that's why we got this really steep shooting up here and this steep going down here, because when we cube a negative number, we're going to expect a negative answer. So we have the basic shape in our minds. What we are doing in this video, and hopefully it won't take too long, is we are looking at some of these particular functions and these cubic equations, and just really quickly trying to give a rough sketch of what this thing looks like. Now, just to recap some of the transformations, if we had something like y equals negative x cubed, this is going to change because this is a reflection, this negative sign. That's going to change the concavity of this. So instead of starting from here, increasing, and then continuing to increase, everything here is going to get reflected. So we're going to start up here, and then we're going to go down. So this graph I've just graphed here is going to be my cubic just reflected down, and that is the effect of this negative here. This thing's going to come into play a little bit later as well. But basically, in order to sketch cubic graphs in factorized form, which we're going to be looking at in this video with 3 factors, there are 3 steps that we need to take. So the first one is going to be, we're trying to find key features of our graphs. So we're going to, with these particular graphs, we're going to find the x-intercepts, we're going to find the y-intercept, and based on the negative sign in front, like we talked about up here, we're going to decide whether it's a positive cubic graph, sort of like this one in black here, or if it is a negative cubic graph, like this one here. So the very last thing we're going to do is we are going to connect the intercepts to sketch a positive or negative cubic graph. Okay, so let's just jump straight into it. We're going to be looking at 2 particular graphs here. This first example, we have y equals x plus 2, x minus 1, and x minus 3. So let's start with the easiest one here. Let's find the y-intercept first. And we remember from way back in linear relationships, and it's come across a lot more since then, we find the y-intercept by setting x equals 0. The y-intercept always occurs when x equals to 0. So if we sub in 0 for all of these x's here, we're going to get y equals 0 plus 2, 0 minus 1, 0 minus 3. This is just like saying 2, because these zeros don't really add anything. This is like saying 2 times minus 1 times minus 3. So once we times these together, we are going to get a y-intercept of positive 6. Next, we're going to find the x-intercepts. So we remember our x-intercepts occur when y equals 0. So setting this, we're going to get 0 equals x plus 2, x minus 1, and x minus 3. Now this guy over here looks very familiar. This thing is what we were doing all of last video. We were looking at, once this was in factorized form, where we notice that each of these brackets are multiplying, we can find our solutions to this equation by using the null factor law. So this just becomes a pretty standard question that we did in the previous video. So in doing this, once again, like we did in the last video, we're going to break this up into 3 separate little mini equations. One is that x plus 2 equals 0, one is that x minus 1 equals 0, and one where x minus 3 equals to 0. And it's just a revision of last video, I should say. So if you need a refresher on this, please go back and watch that video. This is assuming that we are quite comfortable with doing this. So this means that our x-intercepts are -2, +1, and +3. And now we have some pretty significant features, and we're going to check here. Once we times through and expand this, the coefficient of my x cubed, once I times all these 3 together, there's no negative here, so it's going to be a positive cubic. The one like this black one on the right up here. So now that we have these pieces of information, let's just draw up a set of axes. We have x, y. So we had our y-intercept at 6. We had an x-intercept at 1 and an x-intercept at 3, as well as an x-intercept at -2. Okay, and we remember that our cubic was a positive one. So it's going to go up and then somehow make its way back up. Now, if we draw this connecting the dots, I have this intercept here, this intercept here, this one here, and this one here. And remember, we are just doing a rough sketch. It doesn't have to be perfect. But when we draw this, we're going to see that our graph goes up here, then it cuts through the y-intercept, goes down to one of the x-intercepts, and then makes its way up through the final x-intercept. So this guy here is just a rough sketch of the graph we have. Now let's look at one more example just to practice. In this second example, we have the equation y equals -x times x plus 3 and x minus 2. Now straight away you guys should be looking at this negative here and thinking, wait a minute, how is this going to change or transform our cubic? Remember, when we have a negative in front of the x cubed, which this is going to expand out to, we're going to expect a negative cubic. So just a little side note, already by looking at it, we're trying to get a feel for how this thing is going to look. But we're going to go through these exact same steps. First, we want to find out y-intercept, which happens when x equals 0. So substituting in 0 for x, I get this thing here. And I get that my y-intercept is going to be, or 0 times 3 times -2, that's just going to be 0. That's my y-intercept. And now I want to find my x-intercepts. So I get my x-intercepts when y equals to 0. So what do I get? Well, I get 0 equals to -x times x plus 3 times x minus 2. Okay, and once again, it is exactly the same as what we were doing in the last video. So using the null factor law, we set up 3 different mini equations. We get that -x equals 0, that x plus 3 equals 0, and that x minus 2 equals 0. Okay, so the first one's a little bit weird, but this is just saying -x equals to 0. Now, the only way we can get 0 here is if x was 0. So -0 is the same as 0. Or we can think of this as -1 times x, and we divide through by -1, we're going to get the same answer. We get x equals to -3 here, and x equals to 2 here. Okay, so now we have our x-intercepts, and these are 0, -3, and +2. Okay, so I have all the key bits of information. I can draw my axes now. I've got my y and my x. Now I have a y-intercept at 0, which is actually also one of my x-intercepts. So this line can show sort of 2 points. I have -3 over here, and I have +2 over here. So, and I have a negative. What we remember from that point I made right at the start, this negative in front of the x means it is going to be a negative cubic. So it's going in the other direction. So instead of increasing up here, looping around and increasing again, it is going to start decreasing. So here, I'm going to start somewhere above this -3. I decrease until I hit here. I go down, and eventually I'm going to loop back up to hit my x-intercept and y-intercept at 0. And then I continue through it, looping back down, because that's the only other way I can hit my last intercept here. So I get a graph that looks like this. Now, remembering that these 3 things that we established are the keys to graphing these. We want to find first the y-intercept or the x-intercept, doesn't matter which one you find first, but we need 3 bits of information. We need a y-intercept, our x-intercepts, and we need to decide what direction this cubic is going. Does it have a negative in front, like this thing shaded in or highlighted in pink? That means that when we expand this whole thing out, all of these x's are going to multiply together, which is going to give me x cubed. So the coefficient of x cubed is going to be negative here. That is why we get a negative cubic here. Whereas up the top, in the first example, I had all positives in front of my x. So if I expanded out these 3, I would just get x cubed, meaning a positive cubic. But that brings us to the end of this series. Thank you so much for watching, and I'll see you next time.